Ladies and gentlemen, welcome your hosts for today, Professor Roshan Raghav, the Consultant Chief Executive Officer of Lanka Education and Research Network, LEARN, and a Professor in Computer Engineering at the University of Peradeniya, Sri Lanka, and Dr. Damayanti Herat, a Senior Lecturer at the Department of Computer Engineering at the University of Peradeniya, and a Chair of the inaugural APAN 56 conference.
Good morning, ladies and gentlemen. It's an absolute pleasure for us to host you today at the APAN 56 conference, the inauguration of Asia Pacific Advanced Network APAN meetings, conferences. And in fact, we are delighted that we are meeting all of you in Sri Lanka during this season of the year. Which season of the year we are in now?
Season and Sri Lanka. All season, all time around the year is a good season for us. So particularly when our friends and connections are here, so good season.
Absolutely. Sri Lanka would always have something wonderful and exciting to offer you throughout the whole year, in fact. Among the many things that we are proud of as Sri Lankans is the University of Peradeniya, which both of us are affiliated as well, formerly known as University of Ceylon, and which was the first and one of the most pioneering universities in Sri Lanka. The motto of University of Peradeniya goes as Sarvasya Lokanam Sastram. A Sanskrit, it's coming from Sanskrit, and it means knowledge is the eye unto all. Knowledge is the eye unto all. No matter where we are from the world, I believe it is something we all can agree upon. And with the same esteem and essence, let us welcome you all warmly to the APAN 56 Conf.
Okay, right. So let us also welcome you all to the inaugural APAN conference. We call it APAN 56 conference. And the first time in 56 or 55 years, in the 55 times in the making. And when APAN come to its 56th time, we are having APAN 56 and a conference version of it. And just to give you a glimpse of what we mean by conference here. So we are talking about a conference of the research nature, where we have papers, manuscripts submitted, peer-reviewed, and presented, published by a well-known or reputed publisher. So that's the idea. And to begin today's lineup, we'll start with the very first keynote for the day. In fact, we had two keynotes for today. The very first keynote for the day. And the very first keynote is on ABCI and the beyond, the world's first largest open AI infrastructure. And the talk or the keynote speaker is going to be Dr. Takano. And to introduce Dr. Takano formally, I'll invite someone who is very familiar to our APAN community, Dates-san. Please.
Hi, good morning. I'm Susumu Date with the Cyber Media Center at Osaka University. I'm very honored to introduce Dr. Ryose Takano to you all. So, Dr. Ryose Takano is a senior researcher of the Institute of Advanced Industrial Science and Technology, Japan. He received his PhD from the Tokyo University of Agriculture and Technology in 2008. He joined X Inc. in 2003, and then in 2008 moved to AIST. His research interests include system software and high-performance computing. He manages several national projects, including ABCI supercomputer. So today's title of the keynote speech is ABCI and Beyond, the world's first large scale open AI in infrastructure. So please welcome Dr. Ryosei Takano.
Thank you very much for kind introduction, Tat Sensei. Good morning, everyone. And it is very great honor to be invited APAN conference. I'm Ryosei Takano from AST Japan. I'm very enjoyed Sri Lanka, very good, nice local food and beautiful sunset. Anyway, I'd like to talk about ABCI. That is quite unique system dedicated to AI research and development. And also, I will mention about plan for ABCI next. Okay. So let me start AI and computing infrastructure. As you know, neural network is inspired by biological neuron in human brains. And Mark Bradford built perceptron machine in 1958. This is a special purpose analog computer. It is designed for vision recognitions. And after a long and winding history of AI research, deep learning has very successful. From viewpoint of computer architecture, GPU-based cluster system like ABCI dominant infrastructures. Recently, large language model, LLM, and generative AI are rapidly emerging. And also, a quantum computer is promising in future. In my talk, I focus on this area. ChatGPT. I don't think I need to explain what is ChatGPT. We are surprising its highly interactive and general problem-solving capabilities. ChatGPT is built upon GPT-3's LLM. And LLM and generative AI have big potential to transform variety of businesses and industries, like the invention of iPhone, maybe invention of internet. What is language model? Simply say, it is a probability distribution over a sequence of words. It only gives high probabilities to natural sentences. And it does not care about ethics or trustworthiness. For example, if these texts are given, language model produce a list of next words together with probabilities. Here, if language model is large enough, what happens? That's a basic idea of large language model. AI researchers try to address this problem and are using huge amount of computing resources. And they finally found scaling law for large language model. This means as the amount of data and parameter increases, the accuracy increases more and more. Another paper said emergence in performance gain is observed when the model size exceeds a certain threshold, that is 10 to 23rd power flops. These results give us the reason to buy GPU. So AI is now supercomputing problem. This figure shows the amount of computational required to train AI model has exponentially increases, and it is far beyond Moore's law. Blue dots are vision model, and red dots are transformer and LLM model. Now, everyone wants more GPUs, but it is not easy to fully utilize bunch of GPUs. So HPC knowledge and practice are needed. That's why AI and supercomputer, or HPC, are getting close. This slide shows huge investment of tech giants in AI infrastructure. For example, OpenAI uses Microsoft Azure platform. It's 10,000 GPU as of 2020. Meta plan to build their own AI research supercluster with 16,000 GPUs. Google also unveiled their supercomputer with 26,000 GPUs. In Japan, Stability AI, which is a AI startup company known as Stable Diffusion, released Japanese language model with 7 billion parameters. Riken and Fujitsu launched LLM project using Fugaku supercomputer. And also, SoftBank, which is a major carrier in Japan, launch a new company to develop LLM. So anyway, tech giants are making huge investment in their own AI infrastructure. However, it is difficult for individual companies to make large investments in AI infrastructure. This is why we need public and open AI infrastructure. That is ABCI. ABCI is open and leading AI infrastructure in Japan, and it has world-class processing capability and data processing capability. Left bottom photo is overview of ABCI, which consists of 1,200 servers, and total number of GPU is more than 5,000. We also design super green data center for ABCI. We are operating it from October 2018, and this system was upgraded 2 years ago. Large-scale language model building support program to meet the demand for LLM research. For advanced and intermediate users, large enough resources are available anytime. For beginners, web-based GUI tools for designing deep neural network are supported. AI research and development requires not only huge computing resources, but also data, academic insights, and advanced engineering talent. So we at AST hope to serve as a hub for collaboration among private sector, university, and public institutions in the development of human resources, technologies, and infrastructure. This slide shows trend in number of ABCI users and variety of applications. Roughly speaking, we have 3,000 users, and almost 90% users are external users. ABCI is used from AI startup to large general electronics makers. And it is becoming an important infrastructure to support AI R&D in Japan. This is the hardware structure of ABCI. ABCI consists of mainly two parts: high-performance computing system and large volume storage system. In the high-performance computing system, we have two types of nodes. There are more than 4,000 NVIDIA V100 GPUs and 1,800 GPUs. The system can provide 850 petaflops AI flops. MLPerf training is a popular machine learning benchmark with HPC system. And this chart shows 1,500 performance improvement in 4 years. The green bar shows result with ABCI. In 2018, ABCI upgrade world record in training benchmark several times. For example, in 2018 by Sony, in 2019 by Fujitsu. This result shows ABCI is quite powerful infrastructure to compete with tech giants in this field. In 2018, we launched ABCI. At that time, we mainly focused on vision, computing vision. And now, computational performance required for LLM is rapidly increasing. For example, even if we use all resources ABCI for training, for GPT-3 training, it takes 1 week. Therefore, we need greatly enhanced ABCI resources to train this scale of model regularly. Next few slides will introduce AIST ongoing AI researches using ABCI. Current interactive AI, like ChatGPT, is limited to cyberspace only, and the output is predetermined during training. We think technology is needed to understand and intervene in real-world problems. To address real-world problems, it is important to integrate multimodality, including language, audio, image, etc. For example, let's imagine smart factory using robotics. We want to connect several AI services like this, capturing real-world environment information, including audio and images, and generating prompter for input to interactive AI. Interactive AI recognizes current situation, and robot motion generation AI generates action plan program. And robot is working, and the environment situation will be changed. And this loop is executed continuously. Such kind of cyber and real-world fusion AI is direction of AI technologies development that can take advantage of Japan's strengths. Japan already have good quality data and good quality experts in many fields. And also we have mature social system. They are Japan's strengths. And also Japan as a pioneer in challenging social problems such as low birth rate, aging society, risk management for aging infrastructure, and disaster, such as typhoon and earthquakes. In Japan, unfortunately, it is difficult to create a new AI industry like in US and China. So we should empower existing large industries with AI to transform them. There are huge impact of vision recognition without natural images. Sorry. A high quality data set is quite important for real world AI, but collecting and cleansing and labeling data are quite costly. And also, if data is imbalanced in some regions, the result will be biased as well. To address this problem, we propose Fractal DB, which is a framework of pre-training issues. Okay, that makes sense, but you may be wondering, how is performance? We demonstrate better than conventional method, even with pre-training without natural images, and fine-tuning with small number of natural images, which is very surprising result. There are huge impact of from field of Japanese industry, such as logistics, manufacturing, and healthcare. We believe highly competitive AI is feasible. Working. This is an example in medical field. We can build highly accurate image diagnosis support AI while reducing cost by pre-training without natural images. In this case, we use Vision Atom DB. It is not Fractal DB, but it's a quite similar one. After that, we do transfer learning with target domain image, small number of target domain images. It may be very useful in field where the number of use cases, is small, and shortage of doctors. Okay, let's move on to quantum hybrid computing. Go ahead. Last few years, quantum computer being available. This figure, the roadmap of quantum computer based on several technologies: superconductive, silicon-based, trapped ion, and cold atom. Current quantum computer works somehow, but they are small scale and quite noisy. We expected 1,000 logical qubit or error-tolerant qubit will be available by 2030. At this phase, finally, it's going to be not perfect, but useful for real applications. In the past years, many countries have published quantum strategies. They clearly start secure supply chain and reaching end users or killer applications and creating ecosystem. Japanese government formulated 3 strategies so far. A vision of quantum future society is a strategy for social transformation by quantum computers. And it describes 3 ambitious goals by 2030. quantum technology and innovation strategy describe technology roadmap. And last one is industrialization strategy of quantum technologies. It describes a policy and action plan for practical application and industrialization. Based on these strategies, we established QIH, Quantum Technology Innovation Hub. The mission is integrated promotion by industry, academia, and government, from basic research to social implementation. AST has been selected one of 11 organizations. Our mission is to support commercialization of quantum technologies from hardware to solutions. Last month, we launched a new research center named Global Research and Development Center for Business by Quantum AI Technology, in short, G-QUAD. This center had 4 functionalities to establish global collaboration and support commercialization. First one is creation of business and application software. Second one is component and quantum computer evaluation and standards. Third one is device fabrication. And last one is global collaboration platform and human resource development. You may be interested in quantum AI hybrid computer. We plan to build next generation computing platform named ABCIQ that enhances computing resources, computing capability, say multi-extra AI flops, and integrates several types of quantum computing technologies, including quantum inspired machine and quantum circuit simulation. In addition, installation of domestic and foreign quantum computers are planned. We support, through this project, we support creation of use case by combining AI and quantum, and combining AI and optimization in collaboration with industrial user companies. Quantum circuit simulation is already working on ABCI. We are using 5,800 GPUs and Q-quantum accelerated Qiskit simulation. And we have successfully done 41 qubit simulation. As far as I know, this is the world's fastest quantum circuit simulation at that time. The right figure compares performance with other simulation. Blue bar is original Qiskit simulation, and yellow bar shows state-of-the-art simulation named MPI cracks. And green bar shows our GPU accelerated Qiskit simulation. So as you can see, we can achieve more than 3 times faster than MPI cracks. And this software is now available on ABCI. At the last few slides, I'm going back to AI and supercomputer. AI, especially deep learning, has great success. But Richard Sutton, who is a famous AI researcher, said that is bitter lesson. AI researchers make efforts building on human knowledge of the domain in many ways. But general methods that leverage computation are ultimately most effective. In other words, computational power solves all problems. So how fast can supercomputer be? You may know the performance improvement of supercomputers have slowed down since 2017 because of economical and technical reasons. This graph shows performance development of the top 500 ranking. Green dots are some of 500 supercomputers year by year. As you can see, the performance development is slowed down clearly. The only way to get faster computer is to build bigger computers, but economical and energy barriers stand in the way. In last ISC conference in Germany, some professors argue about a technology driver of computing infrastructure had changed from supercomputer to AI and clouds. I think the rapid evolution of AI has been supported by freeride on supercomputer technologies. But road ahead will not be easy. So AI and supercomputer are expected to co-evolve in the future. Let me summarize my talk. ABCI is world's first wide-scale open AI infrastructure. After 5 years operation, the use has expanded from AI startup to general electronics makers, enabling world-class AI research and development. ABCI continued to evolve in response to social and industrial demand, such as generative AI and quantum AI hybrid computing. Finally, ABCI will be available by early 2025. The procurement is undergoing. My concern is Japanese yen is getting weak and weak. Anyway, please keep on watching. Thank you for your attention.
Thank you very much, Dr. Khanna, for your presentation. And please take your seat. So in the keynote, we listened to some of the insights into the infrastructure of how AI systems are built. Understanding this infrastructure is really important. Technology can do marvels, but at the same time, they can also make us delay things, get matters difficult if you don't understand them better, right? So for example, the system which is here seems to be too much now for us to understand and manage. We're bringing them to make our lives better, but even a system like this is difficult for people to understand if you do, or manage better if you can't understand them. Thank you very much for that interesting and valuable talk about ABCI's infrastructure.
APAN 56 Conf is a platform to share and advance knowledge, integrated for the first time to APAN meetings under the theme AI and HPC better together. Why?
Right. You already answered the question a little while ago. Right. So AI, artificial intelligence, and HPC, high performance computing, they are together. They are together to develop the way how technology evolved. Let me just take a moment right now to acknowledge the fact our State Minister for Higher Education is here with us. And he is the minister in charge for our members and us together. Thank you for being here, Dr. Suren Raghavan. Thank you, sir. Just give a round of applause for his presence here. Thank you for being here. No, just thank you for being here. I'll call you a little later. Yeah, be seated, please. I'll call you a little later. Just acknowledging the fact you are here. Thank you. Yeah, that's okay. Thank you. So just to answer Damayanti's question in a little more detail about what the conference theme and how we all are here together, right? So I'll just, in the interest of all of you, and I'm going to repeat a few things that I said at the inaugural session. Things like we started APAN meeting a long time back, and here we are at the 56th APAN meeting. The meeting spans from Monday to Friday. Our usual pattern these days, we have 5-day meetings twice a year. And this time, Learn, Lanka Education Research Network, got the opportunity to host, or the privilege and the opportunity to host this meeting here in Sri Lanka. And we started the meeting on Monday. And this time, alongside the meeting, we also wanted to do a few more things. One of those is the APAN 56 conference, the first conference of this nature within the APAN meetings. So the conference we are inaugurating today under the theme AI and HPC, a theme we believe well suited to the current situation where we are with all this generative AI and the chat GPTs and bots and all that, right? So all of them are on stage. So this is, we think, is the right time to discuss and understand and see how we can utilize such technology for our research and obviously for all the education technology we are involved in our education. So research and education. So that's the idea, and therefore we brought in this APAN 56 conference this time, and we are here today. It's happening finally. Yeah.
Right. Sounds wonderful. With that objective, a PAN 56 conference is organized by APAN and Learn in collaboration with Department of Computer Engineering, University of Peradeniya. And this is the first, to the best of our knowledge, this is the first international conference giving an opportunity for the researchers to publish with Springer CCIS, a conference that is happening in Sri Lanka. And this year, we maintained an acceptance rate of 30% at a PAN 56 Conf. And today, we are having a lineup of 15 presentations. Of course, we started off with 2 keynote speeches, and it will be followed by 15 presentations of novel and original work. And a PAN 56 Conf was preceded by, as was mentioned, by a datathon, and it will be followed by a closing plenary tomorrow discussing on rebuilding Sri Lanka through agriculture, innovation, and technology. Now that sounds like an effort requiring a lot of teamwork, isn't it?
Yes, obviously. In fact, in the inaugural session of APAN meetings, I was talking about team, the team we have, and the connections we have, and all the friends we have and who are here, right? So it was all possible because of all these connections. Now, talking about the conference, usually a conference takes about an year to organize. So we start about a year early. We start putting together a team, starting from the conference chairs. Then we have technical program committees. We have reviewers. Then we put all these together. We put up a website. We get by the way, we also talk to a publisher, get their requirements, all these together. And then what we do, we then publish, call for papers, ask authors to submit papers, send them for reviews, do multiple rounds of reviews, different type of reviews, desk reviews, like reviews at the different places, all that. And then finally, we decide a group of papers to be presented and published. That is what we had to do. So this time, we being crazy, we decided we'll do all these 12 months work in about 3 to 4 months time, right? And thanks to you, actually. Damayanti is the one who said, yes, we'll do it when I asked her, right? And we put together a team, not only local, with our friends from around the globe, from researchers from Japan, China, Singapore, US, Europe. We put all of us together, formed a team, had few chairs, track chairs, all that what I said earlier, we accelerated, condensed, and ran the full blow of everything. We spoke to Springer, and they listed a two-page documents of, okay, this is what you should do, this is what you should have. You should have a acceptance rates of less than 30%, blah, 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 blah. We put all that together, and finally, we are here because of the team and the leadership we had on doing all this together, and obviously all the connections and people and collaborations we had. Thanks to that.
Yes.
So let's now take a moment of our time to introduce our guest of honor, Dr. Surendra Raghavan, who is the State Minister of Education and also Higher Education. So he is, like I said earlier, is Lanka Education Research Network is owned by University Grants Commission and all the state universities. All of them, all the state universities and the University Grants Commission comes under the higher education sector, and therefore he is the minister in subject for this our operation locally. And it's a pleasure to have him with us. And Dr. Surendra Raghavan is also an academic, and he was formerly or earlier, before becoming the minister, was also governor of the Northern Province. Thank you, sir, for being here. And I'll take this opportunity to let him say a few words. Over to you, sir.
Aibawan, Wanakam. Konnichiwa. Ahoya. Good day to you. I see many of our friends from Japan are here. I don't have to express the long relationship we have between these two island nations, politically, technologically, and culturally, as we share the same common faith of Buddhism mostly. So I welcome all of you to be able to be in Colombo, and also other friends from Singapore, India, and our regional friends. Your gathering here is a significant turn point in terms of how 21st century's third decade onward, how we are going to teach, learn, and research. I was born into a time and to a house where there was no electricity. I come from a very humble family. My father was a Marxist, so he was more worried about fixing the world than fixing the family. But during my lifetime, Sri Lanka's rural electrification took place. During my lifetime, we had computers arriving. During my lifetime, we had internet coming. During my lifetime, we had also email and Google search engines and all the other technologies that we are using today. And within about, let's say, 50 years' time, humanity has been completely transformed. And today, as we gather here in beautiful Colombo, we are talking about AI and the future of AI and how it will affect humanity. All what we can imagine, as it has happened during the last 50 years, this technology is going to change our lives, particularly higher education sector. My discipline is political science, so I have little knowledge about what you talked about a few minutes ago. But all technologies, all sciences work within a framework of society, which is finally governed by the way we live, the social contract between the state and the citizen. So that contract between the state and the citizen is going to be influenced, transformed, or even, I would say, replaced by technological intervention into common people's life, like my own story. Therefore, it is important for us to reflect, imagine, and get ready for the changes. Because my second slide will tell you, impossible to ignore. We are in a time and a world where we cannot anymore ignore. As a preparation for getting to know AI technology and how it's going to interact, had talked to about 28 senior professors of various fields in Sri Lanka last 3 to 4 weeks. I had a single question to ask them. What do you think about AI? And how is it going to affect us? Unfortunately, out of the people that I questioned, 90% of them had not been familiarized, or they had the attitude of ignoring it. One historian even asked me, he said, we don't have to dance according to every fancy that comes on the world. That was his attitude towards AI. But we must remember, reality is something we can't ignore. What was introduced in March 22nd this year, the 4th version, has already changed the world. So, ladies and gentlemen, learned men and women, we are custodians, we are caretakers of a major transition between before us and what is going to happen after us. The next generation of learners, citizens, had to be introduced and also ushered, possibly guided towards this new reality. I think a country like Japan has this challenge. You are a country deeply embedded in your own culture. You value elders. You value simplicity. You value not wasting anything. Within that cultural framework, how are we going to introduce AI? For instance, integrity. So my second point was, we are going to face a numeric challenge which we have never learned before. Nobody is going to teach us this because this is first time happening. How are we going to conduct our universities? How are we going to conduct our researches? How are we going to check the final year, final assignment of a social science student's essay? This is going to be a challenge to us. So first point is we can't ignore. Second point is we don't embrace blindly, but we embrace in a manner that can develop our second generation. Therefore, we run into the ethics of education in AI. what I call is politics of algorithms. All these data, this technology can give us a superior analysis, but there are some concerns. Are these mechanisms, these way forward ways, Eurocentric? If that's the case, do they understand our colonial, our historical, our post-colonial sociology, and how AI can interact with such deeply embedded cultural trends? Because end of the day, what we are asking is not new intelligent just data, but we are looking for a just society. So from just data to a just society, where democracy will be everybody's concern, where the most peripheralized citizen will have access to life and quality of life. How can we avoid such dominance that may come from one technologically advanced country than to others? As I mentioned, somebody, I think introduction, they told me I was an academic. I am still an academic. I'm accidentally politician. Me Sinhaleng kiyana pim mantri kiyala. In our system we have where some are called into the government. So they are nicknamed as ping mantris. Pinata hambin mantri kamata tamai hambinne kiyala. බෞද්ධයෙක් හැටියට මං ඉතා සතුටුයි මේ වචනයට. මං අඩු ගානේ ඒ තරම්වත් පින් කරලා තියෙන නිසා. ඒ නිසා දැන් මේ මොහොතේ කරන්න උත්සාහ ගන්නෙත් ඒ පින වැඩි කරගන්නයි. Therefore my aim is to not to work for next election but to work for the next generation. In that it is not merely knowledge. Knowledge can come. For instance, we have talked about quality assurance in higher education, and the European power blocks, power corridors are talking about how to standardize our Washington Accord or our Bologna Accords. But suddenly I realized, I asked the question, you can teach a student of cutlery how to cut a vegetable so stylishly, so beautifully. And that is the standard. You can give the transfer that skill. But who will teach that student, even when you are angry, even you face injustice, not to use the same knife and stab your co-worker? Where is the morality? Who will teach that morality to people? Today, it is a accepted reality. Everybody is asking for skills, advanced analysis. But we from Asia need to stop for a moment and ask ourselves, yes, all that is good, but a world that is broken already, how do we fix that world, contribute to fix that world in terms of access to democracy, access to human rights, and end of the day, freedom of human spirit and quality. So I would leave you with that thought. Yesterday, for entire humanity, it was a success. The success came from our cultural homeland, India, our nearest neighbor. Chandrayaan 3 landed first time the south pole of moon. That's what we read. Chandrayaan, I was told, costed only $75 million. When you are in Colombo, you will see we created a tower for digital transmission called the Lotus Tower. Apparently, the Lotus Tower costed 115 million US dollars. That is almost 40% more than Chandrayaan's cost. So, all our knowledge, all our technology had to ask, is it worth investing in the future versus in symbolic gestures of our cultural advancements? But some of you, Sri Lankans especially, when you leave this room may think, no, we don't have to land in Moon, that's okay. Our Nelum Koluna is more important to us. You may think like that. You have a right to think like that. But ask yourself, are you living for today? Is AI demanding us to live for today? Or we transfer and we become custodians of our future generation, our future Sri Lankan citizens. I wish you all the best. Thank you.
Stay on stage for a second. Thank you. Just not in big trouble. Thank you very much, sir, for that wisdom of words. And I take this opportunity to thank you for being here with us. And I just quickly call our APAN local organizing committee chair to give a small memento to the minister, just a memento about the conference. Please. Thank you.
I'll not say a word.
Yes.
You know, we are a cultural state. In state-making theories, there are like America, Canada, Australia, and New Zealand are called cohesive states because somebody from outside came, conquered that land, and established their rule of law and their culture. So those are called cohesive states. Balahatkar Rajya. Ape ayunga kay anda dhanni rajya ultani. Sri Lanka, but Sri Lanka is a cultural state. Historians have told that 38,000 ago, humanity had been here, but we call Balangoda Manavaya. But we only know 3,000 years culture, just 3,000 years only, written culture. So we don't know still 35,000 cultures. So what happens is, it is important to know whom do you know than what do you know, right, in our culture. So I do not know. So this appreciation is, thank you, I accept that. But anything more than $15 worth in Sri Lankan government rule, I must hand it over to the government, right? And I also will have a question to you, to when I am leaving. Why did you select a Yaksha Mona? Because I am a reformer, and many are thinking like I am a Yakshek. But I will do it. I will do all the reform that I am asked to do, because I went to school in hunger. And I know even today in my country, this beautiful island, there are students. We have 4.4 million students going to school every day morning. Nearly about 10% of them are going without breakfast and not sure about their lunch. I will do all these reforms for their sake. Mirisse Badaginne iskole yana gahanu lameek gana mama dannawa. Mullathiewu wala sereppu dekak nathuwa iskole yana taruna daruwek gana mama dannawa. Egollu wenuwen api me reform kala yutuyi. Vice Chancellor of Open University, I listened to you this morning. We need to do this reform. It is for our generation, and that is our duty. I thank you. Have a good day.
Thank you very much. Thank you very much.
Such an insightful and thought-provoking line of talks we have been having so far. And now it's the time for us to move to our next keynote for the day on another timely topic, high-performance simulation in the age of AI by Professor Simon C. And I cordially invite Professor Francis Lee to introduce the speaker.
Thank you, Minister, for coming for this event. Gracing this event has made it very, very important. And what you say just now is we are custodian and we have to plan for the next generation. Thank you. I'd like to introduce the next speaker, a very, very old friend of mine, someone who has been in the HPC community for a long, long time. I've known him since SGI time. Then he went to Sun Microsystem, and now he's in one of the most powerful company, NVIDIA. He's the global head. Simon C is the global head of NVIDIA AI Technology Center. He's the executive director of ASEAN Applied Research Center, and he holds multiple adjunct positions in KMUTT in Thailand and in China as well. He was adjunct staff in my university, and a fellow colleague see that he has made major impact. He's a visionary, and he is an evangelist for HPC. Let me invite Professor Simon C.
Thank you very much, Francis. And let me just, right. So thank you for the organizers, ministers, for having me here. I must say that this is my first time, and I regret to say that this is my first time to Sri Lanka. It is a very, very good experience. I have a chance to meet up with a lot of very interesting people and have a great conversations. Let me find my clicker. So first of all, I got to do some disclaimer. My background is in applied mathematics. So by training, I'm applied mathematicians. I come into AI by accident. So please do forgive me if I make any mistakes or anything that of irrelevance. Well, I want to start off with a little bit of story over here. As you guys know that the earth is warming. Just before I come here, Hawaii has a wildfire. China has a tremendous rainfall in records that flooded Beijing, southern part of Beijing, and also other part of province nearby Beijing. This is inevitable because the earth is warming. We see the global warming affecting our planet Earth. We are predicting that we are approaching 1.5 as a simulation have shown, 2 degrees Celsius warming, and then go on to 4 degrees Celsius warming. It is going to be a very, very tough time for planet Earth. One of the challenges is that we are going to see a lot of extreme weather. Places that you're going to see that it's going to be dry, extremely dry, or extremely wet, or you have extremely hot, like what you're experiencing now in many places. And this is going to happen in many, many places. What the things is that it's going to drive, like I say again, it's going to drive a lot of extreme weather. The frequency of it is going to increase tremendously. So what are we going to do about this? Not only that, we're going to see all these things. One of the things that people does not notice is that it's going to affect a lot of our health. Places like Sri Lanka or the South Asia, places like Southeast Asia, the tropical region, temperature would slightly increase, but at the same time, it will have longer effect on some of this. And what is going to affect is that you're going to have increase in terms of disease. Malaria is going to be more pervasive. dengue is going to be more pervasive, more prevalent. You're going to see that all over the world. So we are going to see that in this, and we're going to have, how are we going to solve this problem? And one of the things is that we're going to look at it, can we use the Apollo 13 moment to help us to solve some of this? I don't know how many of you have actually experienced the Apollo 13 events. The Apollo 13 is that it is a success and also a failure. Apollo 13 was launched, but to moon, the mission was to land man on the moon. It did not succeed in landing then, but it was a successful project in the sense is that it managed to recover the aircraft, the spacecraft, and also the 3 astronauts, even though you have accident up in the mid of the flight. That's because they use something called the digital twins to actually solve some of this problem. Modeling the Earth, so one of the things is that what we want to do is to model the Earth. Before we can actually solve some of these problems that we see, we need to see how can we actually model the Earth. Modeling the Earth requires a lot of many components, and I'm not going to talk about it too much over here because we are not about climate science, but it consists of many components: atmospherics, hydrospheres, and so forth. It is like a Lego, where we put all these things from the ocean models to the climate models and so forth, all these things together in order for us to do the simulations, to understand it. It also requires a lot of many other things like you need to collect a lot of data, and that is require a huge amount of data going through all the different type of devices, satellites, whatsoever. We need to also put it into a models that are able to model them. And needless to say, we need to be able to understand the physics and time integrations, the whole things together to understand what we are seeing into the future. The modeling challenge is this: it's chaotic. Butterfly effects, modeling the planet Earth is a Navier-Stokes equation, is complex. Incomplete observation. We have never enough devices to actually measure what is going on planet Earth. The scientists are putting in a lot of devices, satellites, whatsoever, to get those data, but it's never enough. And needless to say, we need a short time to solutions. And one of the very challenging thing is a finite resource. And let me talk about it a bit more. The finite resource is at this moment right now. This is what we see. At the moment right now, we are doing roughly about 1 kilometer resolutions on planet Earth, on the model that we have. With the largest supercomputer that is existing on this planet. This is what we can do right now. In order for us to do 100 meters resolution, we need to have about 10,000 times the compute power of what we have right now. In order for us to do a 1 meter resolution, we need to have a machine that's about 100 billion times of what we have right now. Let me just give you a context of what it means. This is a map of Southeast Asia. And I come from Singapore, as some of you may know, and this is where I am. This is the little red dot of Singapore. And the thing is this is 1 degrees resolutions. Technically, it means that I cannot even simulate the weather within Singapore itself using the Earth model. You need to do a local models to just simulate the things. But Singapore is a very warm city because we have a lot of buildings, and it contributes to part of the heat around the region. So we need to do that. To make simulation worse is that the complexity are increased because we tend to know the models better. There are new physics, new chemistries, all coming in every day. At the same time, to do weather model simulation, because because it's a chaotic models, we need to study them statistically. Basically, what it means is that you need to run hundreds of models with different initial conditions to get the results, to get the average and the variance and whatsoever on a statistical basis. So this is how usually a climate scientist do their work. In other words, we need to somehow approximate all these models. Now, in order for us to do all this physics itself, they are all described by a set of very complex equations with a Navier-Stokes equation, electromagnetics, and whatsoever. We need to actually find a way of approximate them. In most of the time, what most of us do in high-performance computing is that we actually discretize the equations into a form that we can actually solve it on a computer. Now, in order to do that, in order to accelerate the physics itself, we need to find a way of finding a surrogate models. In other words, what we want to do is to map them from one manifolds to another manifolds. Basically means that, from a standard, a complex partial differential equations, we're able to reduce them to a much smaller models that we can actually solve them, and yet it retains the fidelity. There are a lot of works that has already been done over here, as you could see, books and published over here. But in order for us to do that, in order for us to move down further to able to do a 1 meters resolution or a 100-meter resolution, we need to do even more. So one of the ways is to look at how do we use data-driven modeling instead of just using the plain physics that we understand. As you guys would know, at the moment right now, one of the things is that if we can, the technology that semiconductors can do is limited. It can accelerate all the way maybe to another a few orders up. But in order for us to increase the compute capability, we must use some form of machine learning technology. So let us take a look at the art of AI algorithms. First of all, many of you would know that neural networks has been around for a long time. The fortunate things about the neural networks is that recently we have proven that neural network is a universal approximator, which means that allow us to approximate a lot of different functions. Also, at the same time, we also do know that neural networks can be shallow. A deep neural network with the REL function allow us to actually can be represented through a shallow network. Basically, it means that we can almost, again, the same things is that we can approximate a lot of very complex function in a very, very simple manner. What this means is that over the years, we can see that neural network can be used in many, many different applications. And over the years, there is, because of the growth of data and also the democratizations of compute, we see that AI has now surpassed human capability. Many of these applications are actually very narrow. By the way, I just want to remind that they are narrow. They are not generalized. What I mean narrow is that it can do one task, it can only do one task extremely well, right? So the current AI algorithms, or what we call the predictive AI, has now picked up a lot of speed. Many people are using it for people counting, facial recognitions, for medical images recognitions, and all sorts of things. So you can actually use the current technology. It's mature enough to be implemented in real life. What is exciting over the last couple of months is the area of generative AI. The generative AI itself is not new. The idea come about in the mid, in fact, is in 2014 or something like this. where you have the variational autoencoders and stuff like this that's been born. And then, of course, you have gangs and other things. What has happened is that recently you have diffusion models, examples of stable diffusion that is out. Again, stable diffusion is not new. Remember that it was, again, the concept came about in 2015. The idea of stable diffusion is rather simple. The whole idea is that you have a input, you put on at every stage, you add in noise, and then you reverse the order by taking out the noise, by learning, and then you learn the functions of how to take out the noise. And basically the equations over there. Don't worry about it too much, but the implementation is not simple. The idea is simple, but the implementation is not. What happened is that now you have grown, you have so many different algorithms. When I show you this chart, is out of date. Every day there is a new algorithm that is came out. So when I show you this, is basically out of date. But what he has done is that he has created a lot of application. These are some of the application from Midjourney, from a static image. Now you can actually generate videos and so forth. Within NVIDIA itself, we have done something called the latent diffusion. And combined with our language model, we can now actually create videos by having a text with it. So just like simply putting a text, you can actually generate a video. And these are in the early stage of research. And this is a 10 seconds or 5-second video. Imagine going forward, we can actually generate out an hour of videos or whatsoever by having a script into it. And that's the reason why, one of the reasons why recently Hollywood has a big protest, basically because they are extremely worried about such a technology that is going to replace a lot of their actors and so forth. There are also other technology. This is Drag Gang from Google's. And this is the new Photoshops, where now you do not have to wait for long times, do your editing. You almost can do it instantaneously. People who are doing content creations are now going to see that their work is going to accelerate and order 10 times, 100 times faster. I want to show you a very interesting thing. I'm not that sure how many of you have watched the movie called The Minority Report. It's an old movie. It's about in 2002. Minority Report is about a pre-cop, basically the girl over here, who has the ability to foresee the future. And she only foresees the future crimes. And what they want to do is to capture all the information that she can predict and then prevent a crime. And that was a story, of Minority Report. Of course, there's a lot of dramas behind it, but that is science fiction. What we see today is that we have ability to capture medical brain images through fMRI. So what if we can do such thing? That if we fit in information into the brain, let it capture capture the information about the brain, and then regenerate it, the information that we can capture from the brain. So this was being done, in fact, in Osaka University. This is the work that's been done, and what they have done is that they input it in the image like this, pass into the person will see it. They capture it with a with fMRI scanner. Using the fMRI scanner's data, they generate out the image. Now, you may say that it is not actually the same, but it's in this early stage, which means that now we can use generative AI that I mentioned earlier, or the diffusion models that can actually do that. There are other places where what you call, this is SIBO. And SIBO, basically what it does, it was that this is on the mouse. And technology basically uses the wave signals from the mice, again feeding in the informations into the mice brain, capture the brain wave, and then produce the predicted videos on the side of it. that is on the minds. Recently, Chinese University of Hong Kong and National University of Singapore has created something that is based on the fMRI scan, but together with a temporal basis. And basically what it did was that it did the same thing with the image. It fit the videos into the human being, capture the MRI scan with temporal information, and then decode it using that video, right, to produce the video. So this is the outcome. This is the input of it, and that is the output. And this is what we can do right now. And this is in the early stage of research. Basically, what is it useful for? One of the challenging things for the neuroscientists or for medical doctors is that we know that people who have schizophrenia, mental disease like schizophrenia, but we don't know what they are thinking about. So people are going to use such a technology to understand what is a schizophrenia patient is thinking about when he's going through some form of lapse. So this is one of the technology that use. The natural language processing, NLP, again, is the earlier speaker has talked about is the talk of the town. Many people have put it through many tests. It has surpassed human in one way or another. The NLP is the ChatGPT is based on something what we call a transformer. And there are very many varieties of it as we speak. Every day, again, there is a new algorithm that came out. The whole idea about transformer is based on a paper called Attention is All You Need. And the idea is just like whether the way that we do things, we pay attention to certain things. And what is that we are now able to code it in a way, basically in the transformer manner, that we are able to pay attention to different words, different images, and so forth. So it has basically the algorithms is simply that. Of course, no, there are many variations. Now, the ChatGPT is not just ChatGPT. There are a lot of applications. Every day there are new applications that sit on top of ChatGPT. These are a subset of it. And like I say again, every time I capture a snapshot of it, I'm out of date because there are new ones every day to come out. But I want to show it to you some of the application of interest to me as a scientist in terms of using large language model. This is the examples of a large language model where you use human language, natural language, to actually produce computer codes. So instead of you having to write in Java or Python or whatsoever, now you can actually use human language, natural language to write that. What it means? Well, you can predict that. It means that we're going to democratize programming, right? But we do know, one of the things that we do know that natural language like ours is ambiguous. It is not very clear. That's why programming language is very, very important. There is things like GPT engineers, and this is where the program would ask the programmer, what does it actually means? And then the programmer will then respond, and then the program will then generate out the necessary code based on the program understanding. So you have things like this. There are many other things. Code translator that is based on large language model. And they are graph GPT, which basically create relationship graph for those who are doing knowledge engineering or whatsoever, or any kind of making use of graph theory. Now you can actually create those graphs almost in real time. But not just that, we can actually use language model to create agents. Agents that is, to a certain extent, autonomous agents. So Hugging Face has produced, they call Hugging Face GPT, where you actually think of it is that it is a task decomposer and also a task assigner. where you assign to different algorithms. Like I mentioned before, there are different algorithms that are capable of doing different things. Now, due to lack of time, I'm going to fast forward a little bit. There are a lot of new things that's all coming out. Things like reflections. Things will be like, like the auto GPTs and so forth. And they are extremely very interesting technology, which actually able to help us in the science area. There are a lot of applications going forward. And one of the things relating back to the science, as you would know, that reading through a lot of this science report is just very, very tedious. So there's something called the chat climate, where you actually able to interact with the board to ask the necessary relevant questions, and you're able then to answer you. But one of the things as engineers, as a computer scientist, what I want to do is to create something like Javas in Iron Man. For those of you who watch Iron Man or the Marvel movie, you know that Javas, the AI that helps Tony to create all these things, is an important tool. This is Crunch GPT. Basically, what it does, of course, you have not reached the stage of Javas yet, but what it does is that, remember, for those who are, especially for those who are doing engineering over here, or CFD, whatsoever, many of the time you spend almost 90% or 80% of the time formulating the problems, trying to figure out what goes wrong with setting up the parameters for your boundary conditions. These programs is able to help you and accelerate you to set up the problem in double quick time. How much time do I still have left? Anyone could answer me? No, I mean the time that I have on the stage. But before you guys are, now, many of you would have been very familiar with AlphaGo. AlphaGo is a very interesting thing, and as you guys would know, it caused a sensations by beating Lisondi in the Go game. But what is interesting over here is the background of the algorithms. The algorithms is a reinforcement learning algorithms. And basically the whole idea is that it's just like a small kids. Every time you make something that you do that is good, you get a reward. You did something wrong, you get the penalty. And if you can cast them in a equations, then you can actually solve the problems. Of course, there are a lot of factors behind it that is make it difficult to solve, because things like unobservable, things like this. It's been used in many things like robotics, autonomous vehicles, and stuff like this. So these algorithms is around. But what is interesting over recently was AlphaGo, DeepMind, who invented AlphaGo, created something called the Deep Tensor. What it does is that he has solved one of the problems that the computer scientists have the longest time trying to solve. It's basically to find a better matrix computation, basically the sensor algorithms, and they have found a new algorithms that is better than the sensor algorithms. So you have a self-learning algorithms that could invent algorithms that's better than human being. The other thing is AlphaDev, which is solving the sorting algorithms. So what it means is that going ahead, as a scientist, as a programmer, I will have all these tools. I have tools that's able to help me to write programs using natural language. I have programs that are able to ask me what is to be more specific in my specifications. I have programs that are able to help me to actually design my problems in a more relevant manner, such that I can get rid of all the mistakes and get it done faster. And I have algorithms that's able to accelerate my development of the systems. So machine learning applying to climate science, thinking of all these type of algorithms, there is a lot of work going on right now. In the predicting AI portion, not the generative AI portion, but this predictive AI portion, there are a lot of work. And this is just a small little subset of it, using it to predict, clouds, precipitations, and so forth. Let me just. Now, one of the things is that we also want to have a mix, because one of the things is that we have in physics itself, we have accumulated so much knowledge over hundreds of years. How do we actually combine those knowledge that we have in physics together with the new technology in machine learning? Something called physics-informed neural network. Basically, it's the combinations of physics, using physics to actually train the neural network itself, not by using data, but using the physics equation. So these are just a bit lack of time. I'm going to go quickly it, I'm not going to go through the equations and stuff like this, but we just want to show it to you that the results for a physics neural informed networks can do a lot of wonderful things, and the results are pretty accurate. Right. We are doing some works in my team with the India teams, and then and we are working some of this work together with Siemens. I'm going to show it to you in our next video. And this is the work that we are doing together with Siemens.
Energy capacity currently exceeds 750 gigawatts and is growing faster than ever, with an additional 650 gigawatts to be added in the next 5 years. For companies like Siemens Gamesa Renewable Energy, optimizing the configuration of each new wind farm is critical for getting the most out of their investment and reducing costs for consumers. When designing a wind farm, it's critical to place each turbine so as to minimize the effects the turbines have on each other due to the wake that they create. Accurately modeling the wake requires high-resolution, high-fidelity simulation data that is specific to that wind farm, such as the geographic location and the terrain. The gold standard for generating this data is the large eddy simulation shown here. But to run just one iteration for a single turbine can take 40 days on a 100-core CPU. And with so many iterations needed to develop an accurate model for a specific site, using CPUs is impractical. Using NVIDIA Modulus and NVIDIA Omniverse, Siemens Gamesa has been able to reduce that 40 days to just 15 minutes, approximately 4,000 times faster. This is accomplished by running the model at a lower resolution, and then, with a physics ML model trained using Modulus, to enhance or super resolve the data. And the results are functionally equivalent to having run the model at full resolution. Let's take a look at the same data presented in a way that clearly highlights the coarseness of the low-resolution simulation. Here, they look like pixelated blobs. In the super-resolved flow field, you can see the finer vortex structures. Now that we have the simulation data, we can build an accurate weight model for the site and optimize the placement of each turbine. Thousands of iterations, accelerated by NVIDIA GPUs, are run as part of the optimization to achieve the maximum power output for each farm while minimizing the cost. And the impact is huge. When using NVIDIA Modulus and Omniverse for a typical 1,000 megawatt offshore wind farm, optimization can provide power to supply up to 20,000 additional homes, and to do it at 10% lower cost.
So, physics-informed neural network is one of the works that we are working on. We have created a package called Modulus, which is open source, that create not just the physics-informed neural work, but also things like deep ONets and so forth. Now, I also want to touch on something that we use, the transformer. Now, one of the things is that, as you would know, that we want to predict extreme weather. And the thing is that predicting extreme weather is extremely challenging. So we have created something what we call a forecast net. And forecast net, basically the whole idea, and let me just go through it, is basically to see how can we actually predict where are all the extreme weather is based on past data. The algorithm itself is rather complex. It consists of what we call a pseudo neural network together with what we and also a transformer. And the things is that the result that we shows is that we are able to forecast extreme weather pretty accurately up to 4 days. Nothing more than that. It's up to 4 days at the moment right now. And the rest of the results, rest of the slides, able to show you over this. The other things that we are also working on that in NVIDIA is something what we call, just to bring it back to the thing, is something what we call a neural operator. Now, what is a neural operator? As many of you will have think about it, is that you solve a differential equation, it is think of it as an operator, right? A differential operator. And what we want to do is to use artificial intelligence to actually learn about the operator. And so what we have done was that the first thing that NVIDIA have done was to develop an algorithm that learn the green function. Again, I don't want to delve on it too much. I will just show you the result on some of these things that we have done. And this is basically the result. This is a spherical Fourier neural operator, and this is the ground truth. And you could see that the results are pretty close. It allows us to actually do this full simulation on a ground truth. Things like this takes thousands of GPUs and days of simulation. For this, we can do it on a very small scale, which then allow us to do this, which means that now we can run multiple models of it in double quick time. What it is that we are trying to approach the 100 meters and fully over into the 1 meter. We need to find new math, new science, and also new algorithms for us to achieve that, because by hardware alone, whether we have super duper GPUs or you have 100,000 pieces of GPU, we cannot achieve that. We need to achieve it through new mathematics, new science, and new algorithms. So in our effort within NVIDIA, we have something called the Earth 2 projects, which is why we are trying to build the digital Earth. We're trying to put all these pieces together through the neural AI to represent the model, and also at the same time to able to ingest all the data. So what we have done was to develop something what we call the Omniverse. And Omniverse is basically a platform that allows us to connect all the different tools together. And what we have done is that with these videos, I'm going to show to you what we are doing with digital twins for planet Earth.
High-resolution weather simulations, as provided by DKRZ's ICON code and vast amounts of observational data, allows us to determine the state of the Earth with unprecedented fidelity. But exploring and working with this data can be a challenge. Technologies like the NVIDIA Omniverse ParaView connector allow scientists to interactively analyze weather and climate data in 3D, to combine information from multiple sources, and to explore what-if scenarios. This takes us ever closer to a realistic, interactive digital twin of the Earth. Let's look at two examples. In August 2019, Hurricane Dorian developed into a massive Category 5 hurricane, causing over $5 billion in damage in the Bahamas and the southeastern US, with sustained winds of 185 miles per hour. Viewing high-resolution simulations like these integrated forecasting system simulations in Omniverse allows scientists to analyze the behavior of storms such as this in detail, interactively, and in full 3D. This not only aids in understanding the physics of weather systems, but also allows inaccuracies in models to be identified and refined. With the Omniverse ParaView connector, visualization modalities of ParaView, like streamlines, become available within Omniverse and can leverage the RTX renderer or be fused with data from other sources. These sources can be static or computed on demand, such as mapping service, surrogate model, or an AI-informed physical model. Here we show AI-based image segmentation of satellite data, which was used to detect flooded areas and to classify land use before and after Dorian hit. The network performing the segmentation can run as a service and be triggered on demand. Once we have interactive access to all this Earth science data, a next step is to play through different scenarios. On-demand evaluation of surrogate models or access to real-time physics engines can help exploring the impact of our actions in this virtual world. With access to real-time physics models as enabled by Omniverse, we can not only explore pre-computed data, but also simulate on the fly. Here, we use real-time fluid dynamics simulation to show the vapor plume emerging from a cooling tower. A user can quickly explore the impact of the plume, depending on the wind conditions or the steam output. Similar models can be used to interactively explore the dispersion of aerosols or contaminants. NVIDIA Omniverse is a powerful platform for massive scale digital twin simulation. We're excited to see where it takes us next.
So this is NVIDIA plans to actually put all these technologies together. Hopefully, we are at the same time, we are working with the various community like yourself to enable us to build a what we call Earth 2, which is a digital twins of the planet Earth. And hopefully such a tools will allow us to solve some of the climate model issue. So thank you. So with that, I thank you very much.
Thank you, Professor Simon C., for that wonderful speech. So we started off by talking about infrastructure supporting AI-driven innovations, and we went to talk about how do we really cope up with these and what we need to do to cope up with these AI-driven innovations. It was absolute privilege for us to have our keynote speakers today, and now I would like to invite the State Minister of Higher Education, Dr. Suren Raghavan, to do the honor of presenting the tokens of appreciation to our two keynote speakers. Yes. And I also invite the two keynote speakers to the stage, please.
Parliamentary Day. So if you had already familiarized with our parliament, the morning hours are very dramatic. Parliament. So there are messages asking me to come soon.
Please.
Thank you very much. Thank you.
Thank you. That brings us to the end of the opening session of APAN 56 Conf. And now we will move to the sessions at the library after this. So we hope that you will have a wonderful experience throughout the day today, listening to the speeches and also exploring the recent work in AI and HPC while enjoying the breeze of Gulf phase and the Sri Lankan hospitality. Thank you and have a great day, everyone.
Wish you all a great day. Thank you very much for being with us. Thank you.